students, I hope all of you are doing good. Let's start today's chapter, Congruency of Triangles and Pythagoras Theorem. Similar figures. Two figures having exactly the same shape are called similar figures. Similar triangles. Two triangles are similar if their corresponding angles are equal. In the given figures, triangle ABC and triangle DEF are similar, as you can see here. Okay, these are similar. Congruent line segments. Two line segments AB and CD are said to be congruent if AB is equals to CD. Congruent angles. Two angles, angle ABC and angle DEF are said to be congruent if their measures are equal. Thus, angle ABC is equals to angle DEF. Okay, and angle ABC is equals to angle DF is equals to 50 degree. Okay. Next, congruent triangles. Two triangles ABC and DEF are said to be congruent if their corresponding sides are congruent and their corresponding angles are congruent. We then write triangle ABC is congruent to triangle DEF. Okay, this is the sign of congruency. Okay, triangle ABC congruent to triangle DEF means that we must have AB is equals to DE, BC is equals to EF and AC is equals to DF, and angle A is equals to angle D, angle B is equals to angle E, and angle C is equals to angle F. Okay. For any two triangles to be congruent, the 6 elements of one triangle need not to be proved equal to the corresponding 6 elements of the other triangle. Axioms. These are true statements that need no proof and are self-evident. For any two triangles to be congruent, the following 4 results are sufficient. Okay. So, axiom 1 is SSS property, that is side, side, side. If 3 sides of one triangle are equal respectively to the corresponding 3 sides of the other, then the triangle are congruent. For example, in triangle ABC and triangle DEF, as you can see, AB is equals to DE, BC is equals to EF and AC is equals to DF. Okay. And axiom 2 is SAS property, that is side, angle, side property. If 2 sides and the included angle of one triangle are equal respectively to the corresponding 2 sides and the included angle of the other, then the two triangles are congruent. In triangle ABC and triangle DEF, AB is equals to DE, AB is equals to DE and AC is equals to DF. Also, angle A is equals to angle D. Axiom 3 is angle side angle, that is ASA property. If 2 angles and included side of one triangle are equal to the 2 angles and included side of the other triangle, then the two triangles are congruent. In triangles ABC and DEF, angle A is equals to angle D, angle B is equals to angle E, also AB is equals to DE, and triangle ABC is congruent to DEF. Okay. Axiom 4, which is RHS property. If the hypotenuse and one side of a right angle triangle are equal respectively to the corresponding hypotenuse and one side of the other right triangle, then the two right triangles are congruent. In the right triangles ABC and DEF, we have hypotenuse AB is equals to hypotenuse DE and the side AC is equals to DF. Therefore, triangle ABC is congruent to triangle DEF. Okay. Now, let's talk about Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equals to the sum of the squares of the other 2 sides. In the given figure, triangle ABC is a right angled at B, that is angle B is equals to 90 degree. AC, this is the hypotenuse. Hence, by Pythagoras theorem, hypotenuse, square of hypotenuse is equals to the square of other 2 sides, that is AB square plus BC square. Right. Converse of Pythagoras theorem is true. If in a triangle the square of the longest side is equal to the sum of the squares of the other 2 sides, then the triangle is a right angled and the angle opposite to the longest side is a right angle. Okay. So, in the given triangle ABC, AC is the longest side and AC square is equals to AB square plus BC square. Then triangle ABC is the right angled at B and AC is the hypotenuse. Let's consider some example. State if the following pairs of triangles are congruent or not. Solution. We know that the sum of 3 angles of a triangle is 180 degree, right? So, here angle A is 50 degree, also angle E is equals to 50 degree, right? This one. E is equals to E. And AC is equals to EF. AC is equals to EF, this is given here. And angle B is equals to angle F, clearly you can see here. And angle C is equals to angle D. So therefore, triangle ABC is congruent to triangle DEF by ASA axiom of congruency, that is angle, side, angle. Okay. Let us consider example number 2 also. State if the following triangles are congruent or not. Okay. So these are the two triangles in the given figure. You can see that here AC is equals to DF. Both are 5 centimeter, and BC is equals to EF. But the included angles are not mentioned as equal. So right, the triangles are not congruent. Okay. Next, congruency of two triangles. Two triangles are congruent if and only if they have exactly the same shape and the same size. Remember that. Test for congruency. Number 1 is SSS. 3 sides of a triangle are equal to the corresponding sides of the other triangle. 2. SAS. 2 sides and the included angle of one triangle are equal to the 2 sides and the included angle of the other triangle. 3rd, ASA. 2 angles and the included side of one triangle are equal to the 2 angles and the included side of the other triangle. 4. RHS. The hypotenuse and the side of one right angle triangle are equal to the hypotenuse and the side of the other right angle triangle. Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. 2. If in a triangle, the square of the longest side is equal to the sum of the squares of the other 2 sides, then the triangle is a right angle triangle and the angle opposite to the longest side is a right angle. Let's do exercise 22.1. State if the following pairs of triangles are congruent or not. Here you can see that this side is equals to this side. Okay. This side is equals to this side and this side is equals to this side. That means these two triangles are congruent. Okay. Similarly, you have to find out whether all these 3 pairs of triangles are congruent or not. So students, now you will do practice of the remaining questions of this exercise.